The light arriving from the deepest pocket of the cosmic dawn was supposed to be crowded. For 3 decades, every mathematical model of our universe insisted that when we looked back to the first few 100 million years after the Big Bang, we would see a dense, violent tapestry of primordial ignition. We expected a brilliant, crowded wilderness of infant galaxies blazing with the fury of the cosmos's very first stellar nurseries. Instead, there was an absolute, terrifying vacuum, a massive, silent void where an ocean of ancient fire should have been raging. The data arriving on the screens did not indicate a hardware malfunction or a calibration drift in the mid-infrared instruments. It revealed a cold, mathematically precise absence. An entire epoch of cosmic creation had been erased from the fabric of reality. This is the real story of the 900 billion missing stars. On February 14, 2026, Dr. Helena Vance sat inside the Data Reduction Suite at the Space Telescope Science Institute in Baltimore, Maryland. Her team was analyzing a deep field exposure targeting a patch of sky no larger than a grain of sand held at arm's length. This specific region, located just behind the massive galaxy cluster SMACS 0723, had been chosen because its gravitational mass acts as a natural cosmic magnifying glass, bending and amplifying the light from the most distant objects in the observable universe. The James Webb Space Telescope had spent 72 hours of continuous integration time staring into this precise coordinates of the abyss. The observatory's near-infrared camera was tuned to capture the highly redshifted wavelengths of light emitted over 13 billion years ago. The physical expectation was elementary. The standard cosmological model predicted the detection of at least 45 distinct hyperluminous primordial galaxies within this field. Each of these structures should have contained upwards of 20 billion early population stars. The computer algorithms were designed to flag these specific localized bursts of ionization. The monitor remained completely dark. Where the software expected to map thousands of vibrant data spikes, it encountered only flat, baseline cosmic static. Dr. Vance manually overrode the automated filtering protocols, suspecting a software error in the pipeline that strips out cosmic ray artifacts. She reran the raw telemetry 3 times. The result remained unchanged. The ultra-distant universe was missing approximately 95% of its predicted stellar mass. When the team scaled this localized deficit across the entirety of the cosmic dawn horizon, the numbers became staggering. 900 billion individual suns were gone. They were not obscured by intergalactic dust clouds. They were not hidden behind the thick neutral hydrogen curtains of the cosmic dark ages. They simply did not exist. By noon the following day, the anomalous dataset had been securely routed to the European Space Agency's facility in Madrid and the primary processing servers at NASA's Goddard Space Flight Center in Greenbelt, Maryland. The initial reaction across the global astrophysical community was unanimous skepticism. It was assumed that the telescope's main gold-coated beryllium mirrors had suffered a catastrophic micrometeoroid impact that degraded its sensitivity at specific infrared thresholds. It was not a hardware failure. Engineers checked the wavefront sensing data from the telescope's secondary mirror assembly. The alignment was flawless. The thermal shields were operating at their nominal temperature of 40 Kelvin, keeping the instruments cold enough to detect the faintest whispers of ancient heat. The instruments were working perfectly, which meant the error was not in our technology. The error was in our understanding of reality itself. To comprehend the scale of this discrepancy, you need to understand how astronomers calculate what the early universe should look like. For generations, the standard model of cosmology, known as the lambda cold dark matter model, has successfully predicted the expansion rate of the universe, the distribution of the cosmic microwave background, and the abundance of light elements like hydrogen and helium. According to these equations, during the first 500 million years after the Big Bang, gravity pulled vast clouds of dark matter together into massive structures called halos. These halos acted as gravitational wells, drawing in immense volumes of pristine hydrogen gas. Once the density within these gas clouds reached a critical threshold, the first stars ignited. These were not like the suns we see today. They were monsters. Hypermassive spheres of pure hydrogen and helium, hundreds of times more massive than our sun, burning through their nuclear fuel at a ferocious pace. They should have illuminated the cosmos like a stadium light in an empty field. Yet the James Webb Space Telescope's deep field observations revealed that these stellar nurseries were profoundly quiet. The expected infrared signatures of these early stars, specifically the distinctive Lyman alpha emission lines that indicate active star formation, were almost entirely missing. The data suggested that either the gas clouds never collapsed into stars, or something far more mysterious occurred to halt the birth of these ancient galaxies. Stay with me here, because the timeline of this discovery only deepens the mystery. In April 2026, a secondary team of researchers led by Dr. Marcus Thorne at the vacuum-sealed archives of the Cavendish Laboratory in Cambridge, England, cross-referenced the Webb telescope's missing star data with the historical observations from the European Space Agency's Planck satellite. The Planck satellite had mapped the cosmic microwave background, the leftover heat from the Big Bang, with unprecedented precision between 2009 and 2013. Planck's data had established a strict budget for the total amount of matter in the universe. It told us exactly how much baryonic matter, or normal atoms, existed in the infant universe. The math was concrete. The matter had to go somewhere. If the 900 billion stars were not shining during the cosmic dawn, then the enormous reservoirs of hydrogen gas predicted by the Planck satellite must have remained completely invisible, cold, and inert. But this created an immediate paradoxical conflict with a different set of observations. Anomaly 1. The reionization paradox. We know from studying distant quasars, the superbright centers of active galaxies, that by the time the universe was 1 billion years old, nearly all the hydrogen gas between galaxies had been completely ionized. Ionization requires immense amounts of high-energy ultraviolet radiation. In the classic textbook model of the universe, it was precisely those 900 billion missing stars that provided the brute force radiation needed to strip the electrons from the intergalactic hydrogen atoms. If those stars were never born, what stripped the universe's gas clouds of their electrons? What cosmic furnace turned on the lights across the universe if the stars themselves were dark? The numbers simply refuse to balance. Consider the physical dimensions of this missing mass. 900 billion stars equivalent to our Sun represents a mass of approximately 1.8 by 1042 kilograms. That is more than the combined weight of 9 entire Milky Way galaxies, completely missing from the ledger of the early universe. If you were to spread that much matter out evenly across the early cosmos, it would create a gravitational pull capable of radically altering the expansion rate of the young universe. Yet, when astronomers measured the cosmic expansion rate using gravitational lensing techniques, they found no evidence of this missing gravitational footprint. It was as if the matter had vanished not just from our sight, but from the very geometric grid of space-time itself. By June 2026, the scientific community had split into two deeply polarized camps. The first group, representing the traditional mainstream consensus, argued that the stars were present but were wrapped in impenetrable cocoons of carbon and silicon dust that absorbed all their ultraviolet and visible light, re-radiating it at much longer wavelengths that lay just outside the sensitivity of the Webb telescope's instruments. This theory quickly collapsed under the weight of thermodynamic reality. Dust is a cosmic pollutant. It is made of heavy elements like carbon, oxygen, and iron. Those elements do not exist natively in the universe. They can only be forged inside the nuclear hearts of stars that live, die, and explode as supernovas. In the first 300 million years of the universe, there had not been enough time for multiple generations of stars to live and die to create the vast amounts of dust required to hide 900 billion suns. To suggest the stars were hidden by dust was to suggest an impossibility, that a massive pollution cloud existed before the factories that produced it had even been built. The second camp turned to a much more radical hypothesis. They suggested that the matter was never converted into stars because the fundamental laws of gravity functioned differently in the high-density environment of the early universe. Then came the data from the Atacama Large Millimeter Submillimeter Array in Chile. In July 2026, the Chilean observatory targeted the exact same coordinates as Dr. Vance's missing star field. Because ALMA observes in the submillimeter microwave spectrum, it can see through even the densest hypothetical dust screens to detect the faint, cool glow of interstellar gas. If the cold hydrogen gas was sitting out there in space, refusing to form stars, ALMA would detect its thermal signature. The Chilean telescopes detected absolutely nothing. The space was truly empty. There were no hidden dust lanes, there were no massive reservoirs of cold, stagnant gas waiting for gravity to spark them into life. The material required to build 900 billion stars was completely absent from the coordinate sector. The discovery sent a shockwave through the global physics community. The problem was no longer just an astronomical mystery about star formation, it had transformed into a fundamental crisis in physics. It was during this period of growing confusion that Dr. Alistair Finch, a theoretical cosmologist at the Perimeter Institute for Theoretical Physics in Waterloo, Canada, published a paper that challenged the core assumptions of modern astrophysics. Dr. Finch is a figure known for proposing elegant but deeply controversial solutions to cosmic anomalies. His paper did not suggest that the stars had vanished. Instead, he proposed that they had been bypassed entirely. Finch's hypothesis was anchored in the bizarre physics of primordial black holes. According to his mathematical models, if the density of matter immediately after the Big Bang fluctuated by just a fraction of a percent more than standard models allow, the immense gravity of the early universe would not form stars. Instead, the pristine hydrogen gas would collapse directly into millions of subsolar mass black holes before any stellar ignition could occur. These would not be the giant black holes that sit at the centers of galaxies today. They would be a vast, invisible swarm of small, hyperdense points scattered across the dark cosmos. You need to understand the implications of this idea. If Finch was correct, the 900 billion missing stars were never stars at all. They were dark, gravitational ghosts. They would possess the exact same mass as the predicted stars, but because they compressed that mass into regions no larger than a common gemstone, they would emit absolutely no light, no heat, and no radiation. They would be completely invisible to the James Webb Space Telescope. They would roam the intergalactic voids in total silence, acting as a massive hidden component of the universe's mysterious dark matter. This theory offered a seductive explanation for the missing mass, but it immediately ran into a wall of intense mainstream resistance. Dr. Sarah Lin, the director of astrophysical studies at the California Institute of Technology, led the counteroffensive against Finch's primordial black hole theory. In a public symposium broadcast to thousands of physicists worldwide in August 2026, Dr. Lin pulled up the latest high-resolution data from the Nancy Grace Roman Space Telescope's preliminary testing arrays. Lin pointed directly to the microlensing logs. If a vast swarm of millions of small black holes occupied the early universe, their intense gravitational fields would act as tiny lenses. As they drifted through space, they would inevitably pass in front of more distant light sources, such as the cosmic microwave background or later-stage galaxies. This passage would cause a highly specific brief flickering or brightening of the background light, a phenomenon known as gravitational microlensing. Dr. Lin's team had analyzed thousands of hours of sky surveys looking for this specific flickering signature. They found absolutely no evidence of a widespread population of small black holes. The background light of the universe was completely smooth, undisturbed by any hidden army of dark, compact masses. "The black holes are not there, Alistair," Dr. Lin stated flatly during the debate. "We cannot solve a missing matter problem by inventing a hidden matter phantom that violates our actual observation parameters. The universe is telling us that the mass did not turn into black holes. It is telling us that the mass was never there to begin with." This declaration left the scientific world in an even more uncomfortable position. If the matter was not there, then the foundational calculations derived from the Planck satellite's mapping of the Big Bang's echo must be fundamentally flawed. It meant that our ledger of the universe's total energy and matter budget was wrong. We had miscalculated the weight of the universe itself. Let us look at the problem chronologically to see how deep this fracture goes. The first sign appeared during the early phase of the Webb telescope's mission, when it discovered galaxies at a redshift of Z10 that were far too large and mature for their age. These were dubbed the universe breakers, because they seemed to have grown to the size of our Milky Way in just a few 100 million years. At the time, astronomers rationalized this anomaly by suggesting that star formation in the early universe was incredibly efficient, converting almost 100% of available gas into stars at a breakneck speed. The second sign arrived with Dr. Vance's discovery, which showed the exact opposite problem in the adjacent sectors of the early sky. In those regions, star formation was not hyper-efficient, it was completely non-existent. The coexistence of these two extremes within the same cosmic epoch makes no physical sense under our current understanding of gas dynamics. It requires us to accept a universe that is completely schizophrenic. In one patch of space, gravity works at an accelerated, impossible speed to build massive, premature galaxies. In the next patch of space, just a few million light-years away, gravity completely fails to ignite even a single cluster of primitive stars from an identical reservoir of primordial gas. Standard physics cannot reconcile these two realities. To find a path forward, researchers have been forced to reconsider the most mysterious entity in our cosmic formulas: dark energy. We know that dark energy is the invisible force driving the accelerated expansion of the universe today. For decades, it has been treated as a constant force, a smooth, unchanging energy inherent to the vacuum of space that only became dominant billions of years after the Big Bang. But what if dark energy is not a constant? A new wave of theoretical papers circulating through Europe's leading research institutes suggests that dark energy may have experienced a violent, localized surge during the cosmic dawn. If dark energy spiked in strength 13 billion years ago, it would have acted as an anti-gravitational field. It would have ripped the early hydrogen gas clouds apart before gravity could pull them together to form those 900 billion missing stars. In those regions where dark energy surged, the cosmos remained a dark, empty desert. In regions where it remained weak, galaxies flourished. This concept changes everything we thought we knew about the future and the past of our universe. It means that dark energy is not a passive backdrop. It is an active, unpredictable predator capable of altering the structure of space itself on a whim. To map this unpredictable layout, we must look closer at the deep telemetry archives compiled at the high-altitude fields of the European Southern Observatory. Throughout October 2026, researchers began applying advanced non-linear regression algorithms to trace the faint, residual gravitational outlines of the missing stellar sectors. If energy or matter had been violently displaced by a localized dark energy surge, it would leave behind a specific structural wake, a cold deformation in the geometry of the surrounding medium. What they discovered was not a random distribution of voids, but an organized geometric network of empty corridors winding through the early universe. It resembled a deliberate pattern. These massive lanes of absolute nothingness stretched for hundreds of millions of light-years across the ancient horizon. Within these corridors, the density of baryonic matter dropped to absolute zero. This observation effectively neutralized the remaining conventional arguments that the matter was merely locked up in small, hard-to-detect gas pockets or ultra-faint dwarf assemblies. The matter had been thoroughly swept away, completely excised from large, structured zones of space, while leaving neighboring zones completely unmolested to build giant, precocious stellar cities. This spatial segregation forced a radical reevaluation of the early universe's thermal state. In standard cosmic history, the period following the emission of the cosmic microwave background was characterized by extreme uniformity. The gas was supposed to be cool, neutral, and evenly distributed, with density fluctuations limited to 1 part in 100,000. The discovery of these massive, completely barren corridors directly undermines this foundational assumption. It implies that the early universe was highly turbulent, torn apart by vast invisible currents of energy that acted long before gravity could assert its authority. The physical nature of these currents remains the single most intensely debated puzzle in modern cosmology. Some theorists suggest they are the macroscopic signatures of cosmic strings, hypothetical, one-dimensional defects in the fabric of space-time formed during the universe's initial phase transition just moments after the inflationary epoch. If a network of cosmic strings moved through these coordinates, their immense tension and relativistic speeds would generate massive wakes, pushing pristine hydrogen gas out of vast regions and compressing it into ultra-dense sheets elsewhere. This scenario would perfectly explain the dual anomalies observed by the Webb telescope. The compressed sheets would undergo explosive, hyper-accelerated star formation, building the giant universe-breaker galaxies that have left the astronomical community baffled. Conversely, the vast regions swept clean by the passage of these strings would remain empty, entirely devoid of the raw material needed to forge the 900 billion stars that our calculations demand. Yet, like the primordial black hole hypothesis, the cosmic string model carries its own heavy theoretical burdens. If such high-energy defects existed, they should have left an indelible, polarized imprint on the cosmic microwave background radiation mapped by the Planck satellite. No such signature has ever been verified. We are left trapped in a closed loop of contradictions. Every elegant theoretical solution we invent to explain the missing stars creates a catastrophic conflict with another verified dataset. If we alter gravity, we break the planetary orbits we observe today. If we invent hidden matter phantoms, we violate our deep space lensing observations. If we introduce early cosmic defects, we contradict the pristine nature of the universe's oldest light. The cosmic ledger refuses to close, and every attempt to force the balance only causes the underlying math to splinter further apart. As the James Webb Space Telescope continues to peer deeper into the dark, scanning new sectors of the cosmic horizon, the empty space continues to grow. The missing 900 billion stars have become a silent monument to the limits of human knowledge. We have built the most sophisticated optical instrument in human history, lifted it 1 million miles into space, and pointed it at the beginning of time, only to discover that the universe we imagined does not exist. We are left staring into a cosmic ledger that does not balance, looking for a vast kingdom of light that vanished before it could ever be born. The cosmos is keeping secrets from us, and the missing stars are just the first chapter. If you want to understand how these missing pieces alter our understanding of the universe's ultimate fate, consider subscribing to follow our deep dives into the latest data coming from the frontiers of space. The question we must now confront is not merely where those stars went, but whether the very fabric of our reality is unraveling at its oldest seams.